All right, good morning, everyone. My name is Hiren Prada. I always like to say it's pronounced as Prada with a T and without the money. Okay. Um, I'm your instructor for EE201. I've been teaching this class for several years, both at Cal Poly and at previous universities. Uh, Brief introduction about myself. I'm originally from India. I came over to do graduate studies at the University of Louisville in Kentucky. Yeah, world far away. I was there for more than a decade. I only came to do my master's, but then I stuck around to do my doctorate PhD. I got my dissertation done in the field of MEMS and microfabrication, basically semiconductor chip manufacturing, which is a big deal nowadays. And then I was offered a postdoctoral research scholar position at UCSB. So I was there for about 17 months, a year and a half, just short of a year and a half. This was back in 2017. And then I applied for and was offered a position of a lecturer here at Cal Poly. And I've been here ever since. Well, actually, not ever since. It was a long break from May of 2022 until December of 2023. As I stated, I was here on a visa. And so visa processing, in case you didn't know, takes a very long time. So I was stuck outside of the country for about 18 months. So I was here in September 18 till May of 2022, and then I just returned. I returned in January of 2024. But I've been teaching this class for a very long time. I love teaching this class, especially I find it's a little bit challenging than normal because many of the students here are here in this classroom because it's like my department is making me take this class, and so I'm taking this class. But no, I kid. This is right now you might not see the importance, but there are several reasons why non-EE students are required to take this class. Well, one thing is you will encounter electrical engineering in many aspects of your careers as engineers. Okay, you'll be working as part of a team when you graduate, and you will be interacting with colleagues from different fields. Some of them who might be electrical engineers. So if you're sitting in a meeting and you're talking about something, then it's important that you should know what you're talking about. You may not be an expert in that subject, but you should be aware of what is going on in that team, right? Minor troubleshooting, minor circuit analysis is part of your, would be a part of your job. So it will happen eventually. The contents of this class, the material, the syllabus is designed by your departments. Your departments tell us what we need to teach you. So everything that takes place in this class is designed by your departments. Okay. And there's a lot of material to go over. What you study in 1 quarter, the E student studies over 3 quarters or 1 academic year. So the E student will go scuba diving, whereas you will only do snorkeling on top of the surface. Okay. We'll also, this is an electrical engineering class, so we'll also not go too deep into the physics of things. This is normal for EE classes also. We have separate classes for semiconductor device physics, right? So we don't go into the physics of things, meaning when we talk about current and voltage, we won't talk about electrons or how electrons move in a circuit or how electrons and holes, have, well, electrons have positive, negative charge, holes have positive charge. So there's a physical basis for every quantity that we talk about, but we won't go too deep into those, physical basis. That's the brief introduction about the class and about me. Most of you have signed up for the homework. There are some students who haven't, but again, there is a paid access code. It's always a challenge trying to find a fine line between providing students the material versus providing a good learning environment for the students. I've been using this this setup for several years, and students have, to the best of my knowledge, students have not had a very strong opposition to paying, because normally, if first time if I was a student and walk into a class and hey, for homework I need to buy like $50 code or $60 code, then it's always like this professor is lazy, doesn't want to do grading, stuff like that, which is a valid point. But this is not about me grading. I can easily get graders from the department, Okay, this is truly about providing the best learning experience, especially for this class, which is a non-EE major class. We have a ton of material to cover through. And this system is set up in such a way that it benefits the student. Okay, so the homework is a massive chunk of your grade. It's not 10%, it's 40% of your grade. There are several assignments spread throughout the quarter. And because of the holiday right up front at the beginning of the quarter, kind of like bunched up in the first week, right? You have a homework due tonight, homework due tomorrow, and then I think it's every single day. But it's based on the prereq material that you have done, okay? What this homework setup does is it provides you an opportunity to refresh your knowledge. And then as we go along, it provides you extra tutorials, video solutions, which are optional, by the way, to actually build the foundation and build your core knowledge about the topic, okay? These tutorials and video solutions are extra credit. These extra credit will count towards your entire category and towards your overall grade. So it's not lost. There is no cap on the overall credit that you earn, meaning any extra credit that you earn in the homework can offset anything that you lose in the quiz or even in the final exam. Okay. I have several students every quarter who end up with more than 100% overall in my entire class. Okay. So last quarter, I had students who ended up with 101%, 104%, meaning it's like an A++. There's no grade as an A+, but you get my point, right? So again, everything that is set up in the course is to the benefit of the students. There are no midterms in my classes. There's a weekly quiz. My target or sweet spot is about 8 quizzes a quarter, which I think we should hit very easily. 8 quizzes very easily equals about 2 midterms, probably even more than 2 midterms. Okay, so homework together is 40%, quizzes completely together is 40%, and the final exam is worth 20%. If you go online to the course website, it might be a bit confusing because there is a ton of information on the website, and I sent several emails about it. First thing about communication is always use your official Cal Poly ID. If you see an email from your professors regarding the class, please open it immediately and take a look. Reading emails and reading announcements is expected of every student. You are now professional on your way to becoming professional engineers, right? Communication is key. You have to be able to communicate, especially in this day and age of emails. Communication is nonstop. That's an unfortunate downside of the internet. One of the unfortunate downsides, okay? I'm very accessible. I'm not a millennial, but I still have my smartphone tied to my hip at all times. So if you send me an email, you send me a message. If I'm not in a class, if I'm 18 hours a week, I'm actually in a class or a lab. But outside of that, I'm very, very quick to respond. So again, use that communication links that are available to you. Okay, so if you go on the website, you have the syllabus, you have the slides, class notebook, everything available to you. Assignments from the left. It's going to show assignments quickly. And then at my end, if I'm going to do student view, but typically students would view assignments by date, right? Because that's more important, obviously. But when you have some time, do it show by type. Okay. When you arrange it by type, you can see discussions and surveys and quizzes, 40%. Homework, mastering engineering, the online homework is worth 30. And then the scanned uploads that you do is 10%. So the homework together is 40%. And again, this is just, I'm repeating what is already there in the syllabus, and I hope students have read through it. And then the final exam is worth 20%. And then instructor evaluations, basically it's showing 0 right now. That's the way Canvas is set up. It's extra credit. It's a little bit of extra work that I ask of students. You can do it. It's optional. You cannot do it. It's fine. It's optional. These are exactly the same questions that are asked at the end of the quarter, right? The official Cal Poly evaluations, which, by the way, we don't even get until the end at the beginning of the next quarter, meaning the evaluations that you performed or submitted last quarter were delivered to professors at the beginning of this quarter. Okay, and these are completely anonymous. It's simply a internet form. There is no space where you need to enter your name There is no information that is collected other than the responses that you send in. Okay, so every week there is a reminder that is available on Canvas. It's simply a form that asks you the questions. And if I open this up for now, it's probably due on Saturday night. And so it's simply the same questions that are asked in the official Cal Poly form. This is kind of an anonymous survey. It's a medium between the students and between me. So if something is not working for you, feel free to write it down in there. You can write "he sucks" in there, but don't just say why. I mean, don't just say sucks. Explain why, so that I can make a course correction in real time, right? If you fill out evaluations at the end of the quarter, that's great. It benefits the students coming after you. But this will benefit you right now. So if something's not working for you, let me know. And I provide extra credit in the term in the amount of up to 2%, meaning across the entire class, I have about 40 students, which there are 43 seats in the class. So there's quite a few students who are absent. I'll talk about that in just a little bit. But let's say 40 of 40 students submit these evaluations, right? That's 100% response rate. So every week I will total that up. And at the end of the quarter, if the response rate is 100%, every student in the class will receive 2 extra points towards their overall grade. Same thing with the anonymous instructor official evaluations at the end of the quarter. That's an additional 1%. So you can have total of 3%, 3 points added directly to your overall grade. Meaning if you end up with like a 87 in the class, you can be bumped up to 190. And again, these are anonymous. So whether you participate or not, every student will receive this extra credit. Okay. All right. So that's it for that. Assignments, as I was saying, it's on Mastering Engineering. There is a purchase code. I'm sorry, there is a purchase price to be paid for the access code. I've negotiated and bargained with Pearson to bring this down. I believe it's 52 right now. It used to be 65 or 70, but I brought it down to 52. If you do have any concerns regarding this, please reach out to me as soon as possible. Okay. But I believe this will provide you the best learning opportunity for this class and this material. You can take this as many times as you need. Okay, there is a due date on there, but late homework is accepted. There's a late penalty of 5% for every day that students is late, but you do not need to ask me for an extension. The students who submit on time, they get the full credit. If you're late by a few days, there's a small deduction for every single day that you're late. Okay. In real life, there are hard deadlines and then there are soft deadlines. Tax returns, are they hard deadlines or soft? Kind of a gray area. If you don't owe the government any money, meaning you own $0, or if you need to get a refund from the government, that deadline is kind of flexible. Okay, as long as you just say, okay, you need more time, it's fine. If you don't file before April 15th, but if you owe the government any money, then there's a penalty. You can still file late, but you have to pay an interest penalty on the money that you owe the government. Okay, so it would seem like a hard deadline, but if you're late, they're not going to throw you in jail. There will be a penalty. That's a monetary penalty. Immigration, hard deadline. Okay, there are hard deadlines. If I overstay my visa by even 1 day, I'd be ineligible for the rest of my life. Okay, the new visa that I obtained, the work visa that I obtained to enter in the US had a start date of 29th. I cannot enter the country 10 days before the start date of the quarter, which is January 8th. So the 10 days before that is January 29th. I landed in LAX on the night of the 29th, and the immigration official tells me that I was pushing it. And I was like, I have to get the work done. I have to set up Canvas course websites. I have to meet. I have to do paperwork that I have to turn into HR. So I can't be helped. But you can't say anything to those because they have the power to send me back directly from there. If they don't like my face, they don't like me. They said, go back. It happens. Anyway, so that's about hard deadlines. So in life, there are hard deadlines, there are soft deadlines. Homework has a deadline. It's a soft deadline, right? If you are on time, you get You get the points that you earn. If you're late, 5% is deducted. Every question has a max of 30 attempts. Every attempt that you make will cost you about 3%. Again, the point is not to penalize students, but to actually encourage students to actually learn. Okay, that's the point. So that's how the homework is set up. Typically, I do all of this on Monday. I just, because of the holiday, it just screws everything up. So I'm going to move on. If you have any questions about the assignments, about anything else, you let me know via email, via message. Office hours are listed on here. So you have the green office hours space where I'm guaranteed to be in the office. I'm also in my office any other time. I have an open door policy, meaning students can come and see me anytime they want. Obviously, outside of these 3 hours, where I'm not in my office, students can come and see me anytime. Even during the red times, if you have like a quick question, I'd be happy to answer. Okay. So I might have I might be on a lunch break. I might be in a department meeting, office, a different lab room. Just check with me, send me an email saying that, hey, Professor Trotter, I had a quick question. Can I stop by? I'll say, yeah, I'm in the office, come. Lab times, I'm in the lab, building 20, room 126. All 3 labs are in the same lab room. Marked in orange, E251. Some of you are enrolled in my class. You can stop by even during the lab times. Okay, my focus will be on the focus and priority will be the lab students. But if there are a few minutes between, lab benches, there might be 5 minutes, 10 minutes, I'd be happy to answer your questions. So you can even stop by when I'm teaching the lab class. It's absolutely fine, right? Mondays, I have reserved for like student lab meetings, but this is going to be flexible. So this might change in the coming few weeks. Okay, but again, I'm happy to meet in person. I'm happy to meet over Zoom. You need something on a Saturday night, send me an email. If I cannot answer via email, we'll meet on Zoom and clear it out in a few minutes. Okay, like really, Saturday night, if if I'm available, I'm happy to meet over Zoom. It's fine. Try it out. Let's see. So that's office hours, and then class material slides are already up there. I also stated this in my email. Download it any way you want. You can print it out. You can have it on your tablets, your laptops. There's a complex numbers practice sheet where you will be required to do complex math later on in this quarter in a few weeks. And that is the purpose of asking students the question in the discussion forum, which calculator do you use? Thankfully, most of the models are common, right? Texas Instruments TI-83, TI-84, Casio FX115. My calculator is from the 90s, Casio FX100, state of the art, 30 years ago. And I'm still hesitant to give it up. I'm just very comfortable using it. I like new technology, using it, but for some reason, I just don't want to upgrade my calculator. I don't know why. The battery on that has been changed just once in all these years. Just once. And I use it every single day. Anyway, complex number math. So as engineers in your own field, you will use complex numbers at some point. You may have used it in the past. You may have to use it again in the future sometime. So it's not specific just for this class. Electrical engineering, I is used and reserved for anyone? I, what does I note? Current. I notes current in electrical engineering. Hence, we use J. So complex numbers in electrical engineering are represented, or the imaginary number is represented by the letter J, lowercase j. Okay, so if you see J in here, that's what it is representing. Each and every student needs to be able to perform these mathematical calculations on your own calculator devices. You need to be an expert in programming these, whether you perform the manual calculations or whether you type in everything all at once, meaning you can perform this calculation manually. That's the way we used to do it. But programmable calculators, you can simply program the entire equation in there all at once, and it spits out one answer. So if you don't know how to do it yet on your calculators, you need to look up resources, go online, go on the internet, look up videos, tutorials, use the device manual, reach out to your peers who have the same devices, and then learn how to use those. And then finally, that's for the slides. Let's get to the class notebook, which is right here. So class notebook is basically Microsoft OneNote. If you have never used it before, it's a very powerful piece of software. It's free, especially as college students. This is a digital notebook, incredibly powerful in its features and very, very useful. Okay, and you know, it's free for everybody, not just because of it. It's free to the general public. Okay, but you also have a subscription through Cal Poly. You can tie your account through here. The feature that I use is the class notebook, meaning students sign up. I set up the class notebook at my end. Students sign up through Canvas and their account is automatically linked here. Anything and everything that I do at my end is automatically replicated at the student's end in real time. So several students have signed up. If I go into section 3, all three of them are same, by the way. And if I write something here, handwriting is a lost art, by the way. If you can't read my chicken scratch, sometimes I go fast and it's going to be, you know, might not understand what I'm writing, then let me know. Okay. Anyone know the sentence? It's to practice your handwriting because it contains every single alphabet of the English language. A through Z, all of it. Anyway, whatever I annotate at this end, I like using this. This is a digital whiteboard. I call it a digital whiteboard, and I use it for every single class. It is broadcast online. So this is the shared screen feature that you see here. Everything that you see here in person is also broadcast online on Zoom. So you can attend class in person, you can attend class online. You can choose not to attend either and just watch the lecture videos. So everything that you see on the screen and my voice are the only things that are being recorded. If you are attending online, cameras are not recorded, right? If you ask me a question, if you're online, you can ask me a question. I cannot monitor the chat window. Okay, I cannot monitor the chat window. So if you're online, just simply unmute yourself and speak up. Anyway, so attendance, I do not mandate attendance. I do not take attendance. You are adults. I treat you as adults. You are in charge of your own education. If you feel tired, if you feel sleepy, you do not wish to come to classroom, it's fine. If you wish to come to classroom, you need a place to nap, you can come here and nap. It's not going to offend me. You can come into class for 10 minutes and leave. It's fine. I absolutely do not have a problem with that. Okay. You're not going to offend me. If you're late, if you are late by 15 minutes, by 20 minutes, walk in. It's fine. You don't need to ask for permission. If you're going to be absent, you don't need to notify me unless it's on a Monday, which is a quiz day. Okay. If you wish to attend online, you can attend any of the 3 sections, 9, 10, 11, doesn't really matter. Whatever works for you. Okay. Again, unless it's a quiz day, because your quiz is tied to your Canvas, which has a time limit, you know, it's time to your class time, 9, 10, and 11. Yes. 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 Quizzes can be taken online. You can't take online. So there are certain rules. It's on the quiz page. Cameras need to be on for proctoring purposes, especially towards your work area. So students can take quizzes online, but you still just need to let me know if you're taking it at a different time. Okay. So again, OneNote is shared on Zoom, is projected in the classroom. You can see in person, you can see it online. It is also recorded and posted online for later viewing. Okay. And the annotations and anything I write here is available to students in real time at their end. So any questions? All right, let's get into KCL. That took up about, wow, 25 minutes. Yeah, let's see. So KCL, everybody remember that? Hopefully. Let's start with this. What is this called? It's a dot, it's a point. It's a junction. It's a junction, and electrically speaking, It's a node. So a node is any place in a circuit where two or more connections come together. So it's a junction of two or more components. Okay, two or more components. The lines that you see are wires. Okay, lines that you see are wires. They're just making a connection from one component to the next. Okay. Wires are conductors that make connections. They are called as conductors because they conduct electricity. They provide a pathway for the electrons to flow through. Okay. Wires can be short, wires can be long. In circuit analysis on paper, it is all theoretical analysis, so everything is ideal. When we say ideal, we mean we don't take real practical considerations into account. Okay, so a wire can be a dot, can be a short line, can be a dash, short line, could be a long line. They're all treated the same. They all have 0 ohm resistance. Okay, 0 ohm resistance. So wires are ideal, nodes are ideal. All wires connected to one junction or one node are basically that node itself. Okay, so when I say a node is not just a tiny dot. Node contains all of the wires also. A real life example would be your extension cables, power extension cable. You've seen those orange, yellow extension cables, right? If you plug it into a power outlet, let's say you're a 25-foot extension cable, you plug it into a power outlet. What do you expect at the other end? You would expect it to work, right? If it's a 100-foot cable, you would still expect it to work. Okay. Practically in real life, that extension cable will have some resistance. It'll be very, very small, few ohms, but it'll still be there. It just does not rise to the level of interference. Make sense? 100-foot extension cable will still give you the power outlet voltage at the other end. Doesn't matter, it's 100-foot long. Okay, so similar to that, it doesn't really matter how long these wires are, they are still the exact same node. General knowledge question: what is the voltage rating of the power outlet in North America? General knowledge question. Anyone? Without looking it up. 110 to 120 volts. Now tell me you are aware of that. You've heard of that. Come on. General knowledge. Okay. Outside of North America, some places in Europe, some places in most places in Asia, they are 230 or 240 volts. Okay. There is a reason for that. I want to get into that slide, but you just don't have enough time for today. So maybe on Friday, I'll get into it. Okay. But anyway, the point being that if you plug in a 100-foot extension cable into a power outlet, 100 feet away, you would still expect to get 120 volts. It would not, it might be 119, 118 perhaps, but it does not rise to the level of interference, meaning it's not going to fall to like 50 volts so that your device doesn't work. Okay, that's not going to happen. Every cable, every conductor, even a simple cable like this, has resistance, it has inductance, and it has capacitance. But the values of those quantities do not rise to the level of interference. If you take an HDMI cable, plug a 3 feet long HDMI cable, it'll have resistance, but it will work just fine. If you extend that cable to 25 feet long, now that resistance or the inductance will rise to the level of interference. Okay, so 25-foot HDMI cable might not work without special equipment. So anyway, everything that we do in circuit analysis is theoretical. It's ideal. All components are ideal. All wires are ideal. So the nodes that we talk about is not simply a dot. It encompasses all the wires that are making the connections between the junctions. Okay. These wires, these conductors allow or permit the flow of electrons. They provide a pathway for electrons to flow. When electrons flow, energy is transferred. When energy is transferred, we say it is the flow of electric current. So electric current is defined as the rate of flow of charge. That is one of the questions in one of the homework problems. Okay, electric current is nothing but the rate at which charge is transferred. It's the rate of flow of charge. The unit is named after ampere. Electric current is noted by lowercase I or uppercase I, and unit is ampere or uppercase A, or amp for short. Amp or amps for short. Okay. Electrons flow one way and electric current flow the other way. So we have something known as electron flow and hole flow. Holes are the opposite of electrons. So when an electron moves out of its space or its designated spot, it leaves behind an empty space, an empty hole. Electrons have negative charge. Again, we'll go a little bit into the physics. Electrons have negative charge. When they move out, you have an excess of positive charge. Make sense? Right? Those are known as holes. Literally, they couldn't come up with a better word. Holes. In semiconductor device physics, we deal with electrons and holes. Holes have positive charge, electrons have negative charge. When electrons flow in one direction, we say the energy is being transferred. The current direction is opposite. It's the flow of holes. Okay, so the current is flowing in the direction of the holes. Anyway, we don't have to worry too much about the electron flow. Again, this is an electrical engineering class, not a physics class. So do not get too bogged down into where the electrons are moving. In this case, in this example, we are shown that IA is moving upwards. Right? IA is moving upwards. Then we are also shown IC moving towards the left, clashing. And then we see IB coming down. If this was a vehicular traffic diagram, what could we say about IA, IC, and IB? Let's say there was a traffic light at that junction N1. You would say, first of all of them are one-way streets, right? And that is true. Electrical current would be a one-way street. Would not physically have currents moving in two directions in the exact same branch of circuit. Okay, they're always one-way streets. So if this was a vehicular traffic diagram, I would say IA and IC are coming into the junction, and then IB is leaving the junction. So IA and IC are being combined to give us IB. Mathematically, I would write at N1, IA plus IC is equal to IB. And with a mathematical description, general knowledge, qualitative description would simply be IA and IC are combining to give me IB. Make sense? And that is KCL, Kirchhoff's law. Mathematically, all the currents entering a junction, I place on the left side of the equation. All the currents leaving the junction, I place it on the right side of the equation. And you have a mathematical description. You have studied KCL and KVL far longer than you would study it in this class. In this class, what you would do is you would apply KVL and KCL to generate equations for other analysis methods. If you have a preferred way of applying KCL and KVL, you stick with it. You do not have to do what I do, okay? Especially with KVL, right? KCL is far simpler than KVL in terms of writing the mathematical expression. So if you have a preferred method of using KCL and KVL that you've learned in the past, you can continue to do so. All I care about is that you know how to apply it. Okay, you don't have to do this. But KCL, again, simply put, all the currents entering a junction on the left side, all the currents leaving the junction on the right side. As simple as that. How about IA and IE? Does that make sense? Physically? Physically doesn't make sense, no. Theoretically, yes, it could work. The only thing is, mathematically, we'd put a minus sign in front of one of those currents, right? So if I was to write a KCL expression, let me call this N2 and N3. So at N3, I would have IA is leaving the junction. IE is also leaving the junction. Actually, according to my description, nothing is entering the junction, so it's 0 on the left side. And IA and IE are both leaving. So mathematically, this gives me IA equals minus IE, or IE is equal to minus IA. And that's all it is, right? We put a minus sign in front of the currents to balance out the equations. In real life, voltage, current, power, energy, they are never negative. We would not say a power adapter, like my cell phone charger is like 10 watts. I would not say it's minus 10 watts. I would simply say it's 10 watts. But if I was to write a mathematical expression regarding that charger, I would have to put a plus and a minus sign in some places to balance out my equations. Law of conservation of energy, right? Energy is always transferred in one form or the other, right? Electrical energy is converted to mechanical energy, mechanical to electrical. So it's one form converted to another form. So power could be supplied or power could be received. We put a plus or a minus sign in front of those to balance out our equations. So current IA and IE are the exact same current. You're just noting it as opposite just because, well, just to make a point. If you apply, does that make sense? Right? The negative signs. If you look at node 2, what do you see? How many currents are entering? All of them. All of them are entering. So we have IB, ID, and IE entering, and no currents leaving. Is that possible? Only in Die Hard 4. Anyone remember that scene? You've seen that movie? There's a scene in the movie where these software guys hijack all the traffic signals and they turn all lights green. So all vehicles are converging at a single junction. Not possible. IE, IB, ID all entering the junction, but mathematically speaking, either one or two of those would turn out to be negative. Okay. So let's see if we can solve this. IA plus IC is equal to IB. 6 plus minus 2 is IB. Gives me IB as 4 amps, right? And then IA plus IE simply means IE is equal to minus 6 amps. Minus 6 amps. And then, of course, IB, ID, and IE is equal to 0. So plug in values 4 plus, let's see, ID is the opposite of IC. So this 2 amps. So 4 plus 2 plus IE is minus 6. It'll be 0. All right, 10-second pause. Think over it. Let me know if you have any questions. Online students, again, as a reminder, if you have any questions, just speak up. Okay, the speakers in the classroom are on and at a sufficiently loud volume. I would not be able to monitor the chat window. All right, any questions so far? Make sense? So far, so good? Okay. So quickly look at the other examples. KCL. 2 currents entering, so 1 plus 3 equals IA. For part B, I have 1, 2, and 3 currents entering. 1, 2, and 3. And so it would be IB plus 3 plus 1 equals 2. And then for C, we have die-hard 4 again. You have IC plus 1 plus 4 plus 2, plus 3 equals 0. All 4 currents are entering the junction, which of course is not possible. Any questions? So now when current flows through a circuit, it flows through a component. That component will have some resistance. It'll cause a drop in the voltage. Okay. Voltage is defined as, anyone? The rate at which the energy is transferred. Okay. The rate at which the energy is transferred for every single unit of charge. Okay. So the rate at which energy is transferred is defined as the voltage. That is another question in one of the homework problems. Okay, one of the homework. So of course it comes out to be current is coulombs per second. That's the answer. Noted as ampere. Voltage is joules per second, named after volta. And so the unit is volts. Voltage is also defined as the difference in electric potential between any 2 points. Okay. Difference in electric potential between any 2 points. So again, it's the rate at which the energy is transferred. Unit is volt, noted by the uppercase V. So how many of you have heard of ground? Might have heard of electrical ground, right? You might have encountered in physics, noted by a short triangle at the end of a wire. Literally is, there is, you might have seen some outside a electric power station or a light pole where it literally takes excess current, it goes into the ground. Okay. Suffice to say, just again, without going too much into the physics or the theory, think of it as 0 volts potential. Think of it as a base. Okay. So if I say that the surface of this table is ground, 0 volts as my reference, and I raise my right hand to a level of say 5, right? You would say that the difference in potential between my right hand and the surface of the table is 5 volts. If I raise my left hand to 5 volts, it would still be 0 to 5 volts, right? Same level. But if I ask you, what is the difference in potential? What is the voltage between these 2 points? What is the answer? 0, right? It's easy to visualize like this. So voltage is nothing but the difference in electric potential between any 2 points in a circuit. It's always measured across. So you don't have to break the circuit to measure the voltage. Current always flows through a conductor or a pathway. So you have to actually break the circuit, insert the meter in the middle to actually measure. But voltage is measured across. So you measure between 2 points. You're directly measuring the difference between any 2 points. The important point is that you need a reference point for measurement. Okay. So for a voltage, there is always a reference point for measurement. In this case, if you look at the circuit, you have 5 elements, A, B, C, D, E, and each of these elements has a voltage noted as VA, VB, VC, VD, and VE. Both ends of that component, of each component, have either a plus or a minus sign. The plus and minus sign indicates the polarity of the voltage. All it is indicating is which point or which end of that component is higher than the other. That's it. Plus and minus, intuitively, which one is higher? Plus. Plus and minus, plus is the higher. All it is telling you is that the upper end of A is higher than the lower end of A. Okay, I'm using upper and lower in the sense that physically laid out here. Okay, so plus and minus simply indicates which end of the component or which end of the voltage is higher than the other end. And that's why you would end up with a minus, minus, and a plus at the exact same node. The plus and the minus sign only refer to the voltage of that component. It is not referring to anything else. Okay, that's why you have the 3 signs at that exact same junction. Students sometimes are confused. How can you have like minus, minus, and plus at the exact same point? Well, it is only referring to that particular element, B, C, and D, and that's it. Okay, so they do not relate to each other. So KVL, like KCL, is based on the law of conservation of energy. It's actually very beautiful. You take an electrical loop and you add up all the voltages around that loop, they will always sum up to 0. So electrical loop is any closed pathway. And you can see here, you have loop 1, loop 2, and you have loop 3, which is the outer loop. So loop can have nested loops inside it, right? Complicated circuits will have hundreds of loops, hundreds of thousands of loops. Okay, here we have 3 loops. The 2 loops inside are easily evident. The outside one is not so, but that's loop 3. Okay, so the way I always apply KVL, and again, you do not have to follow the way I do it. If I apply KVL, the first thing I do is I pick a starting point, and I pick my loop, and I note down all the voltages I have. So in this case, it's VA, VB, and VC. And they should sum up to 0. Okay, 3 voltages, A, B, and C, they should sum up to 0. Then I pick a direction, clockwise or counterclockwise, starting from any point in that loop. I start at the bottom left corner, and I start driving around that loop. The first sign I encounter is the sign I would put in the equation. Meaning for A, it is minus, so minus VA. For B, it's plus, so plus VB. For C, again, it's plus, so plus VC equals to 0. That's how I write my KVL equations. And again, if you have a particular way or method to write your KVL equations, that is absolutely fine. You stick with what you know. You do not have to learn this. Okay, as long as you are able to apply it correctly, I don't really care. Okay, so I know time is up. I'm just going to write out the expression for loop 3, and then we'll end class. So loop 3, the outer loop, I have 4 voltages, VA, VB, VD, and VE, which sum up to 0. VA is again minus, VB is plus, VD is minus, and VE is plus. Right? If you go counterclockwise, you'd still end up with the exact same equation. The plus and the minus signs will be flipped, but the equation will still be exactly the same. Okay. All right, we'll end class here today. If you have any questions, I have 10 minutes before my next class begins. I'm happy to answer those. Otherwise, I'll see you all on Friday. If you have any questions regarding anything, please reach out to me. I will be in my office all day. I will be in the lab class from 3 to 6. So I'll be able to meet students during 3 to 6 also. All right. E